Okay, this is a quick video tutorial on seismic analysis of RCC structure in STAAD Pro. This is basically a comparison between a manual process and STAAD Pro calculations. So we have a 10-story OMRF building and which has a height of 3 meter. Dead load is 4 kN per meter square, partition load is 2 kN per meter square, live load is 3 kN, and on roof the live load is 1.5 kN per meter square, and the location is at Delhi and soil type is hard. So we have to first choose the beam size. Beam size is 300 by 600, column size is 600 by 300. Size of a building, you can see this is a plan. All the live load, dead load, soil type, everything is there. So the next step will be calculating the factors, that is zone factor, importance factor and reduction factor, which we can get from IS 1893 for seismic code. And this is a floor area, dead load, all partition load, everything this is given in the question. So the next part is calculate the weight. First, typical floor weight, which is except the roof. So this is dead load plus partition load plus 25% of the live load. For seismic calculation, we include 25% of the live load. So we get 6.75 kN per meter square. Now for the roof, it will be just dead load, no partition load, no live load. So 4 kN per meter square. Weight of beam. So for the weight of beam, we'll 0.3 into 0.6, which is width and depth of the beam, and 240 is total length of the beam, like 6 into 6 into 6 into. So this will be 24 into how many times? 5. 24 into 10. So 24 into 10, 240. So we get here 240, and into 25 is the density of RC concrete. So we get 1080 kilonewton. Now weight of column. Weight of column will be 0.3 into 0.6, which is size. Now 2.4 is the height of column. 25 is number of columns. And you will see here 5 here, and total 5 into 5, 25. So 25 columns and 25 is the density. So we will get equal to 270 kN. Now weight of column on roof, which will be the half of total weight of column, that will be half into 270 equal to 135. Similarly, we get a plan. Now we calculate equivalent load on roof, which will be the addition of this and beam and column, which will be the addition of dead load, of beam dead load and column dead load, slab dead load, beam dead load and column. So after adding all of them, we get half from here. Okay, 4 into, what is 4? 4 into 4 is the dead load. For roof level, the dead load is 4 kN per meter square. So 4 into 576 plus 1080, which is the beam load, plus 135 to the column, that is half. Okay, and equivalent load for floor. Floor weight will be 6.75 into 576, which is the area. So slab load into area, we calculated, plus 1080, which is a column. Weight of beam, this is weight of column, 270 we get here. So now we will add them all, add all the floor loads. That will be roof level load plus 9 times this equivalent floor load. So after that we'll calculate the fundamental frequency 0.075, this is to 0.75. We get this formula from IS 1893 and we get 0.96. So after calculating, we will calculate the base shear, and the base shear comes to 2107.5. So we get this table. Now we will see how to do this in STAAD Pro. So when you open STAAD Pro, you will get this. Simply we have to go to geometry and structure wizard, effective frame model, pay frame. What is the length? It was 24 according to the plan. When you will see, height is 30 meter because it's 10 story, 3 meter each size, and width is 24. This will be 4, this will be 10 because it is 10 story, and click on apply. So we get a model here. We will transfer it to STAAD Pro. Yes, okay, we'll switch off the grid. So we have our model. First step will be aligning the property. Go to Generals, Property tab, Define, select Rectangle. In rectangular, first we will define as beam. Beam is 0.6 by 0.3. So this will be 0.3. 6, that is the depth of beam. Width of beam is 0.3. Click on add. Now similarly for column 0.3 and 0.6. So click on add. So beam and column has been now assigned to the structure. Go to select beam parallel to X, select beam parallel to Z, click on assign, yes. So it has been assigned now for column. Select beam parallel to Y, oh sorry, just click here, select beam parallel to Y, click on assign, yes. So beams and columns property has been assigned, as you can see here in 3D render. It has been assigned. Now the next part will be assignment support. Go to support, create support, we need fixed support, add. Now we will assign the fixed support here. Just select it like this. Assign to selected mode, assign yes. So the support has been assigned. Now the next part is load definition. For load definition, we'll first define the seismic load. So for seismic load, click on seismic definition, add. So seismic parameters, which code we are using? We are using IS 1893 2002. So this is the code. Click on generate. Which city it is in? Delhi. Just click Delhi. Okay, so zone factor it has taken automatically. Now this is OMR if building as mentioned in the question. OMR building reduction factor becomes 3. Importance factor is 1. Hard soil, RC frame, damping ratio is 5%. Now this is important, period in X and period in Z. So period in X we have calculated here, as you see, 0.075 H raised to 0.75, which is 0.96. So this is the period in X and period in Z. So 0.96 here, 0.96 here, and click on generate. Everything has been generated here. You can cross check it. 5% damping ratio, 0.96, 0.96, all the values are, and then we'll click on add. So this factor has been added. Now the next thing is adding sulfate. Click on add. Sulfate has been added. Now flow rate. First flow rate was, as you see, the first flow rate was 6.75 kilonewton per meter square, which was a dead load. When you will see here, okay, so first flow rate was 6.75 kilonewton per meter square, right? Dead load plus 25% live load, which is for typical flow. So keeping in mind that, we will just add here first flow rate 6.75 kilonewton per meter square. What was the wide range of it? 3 meter to 27 meter, not 30 meter, because roof load is 4 kilonewton per meter square, which we will add later. So this we have added. Click on add. Now another for dead load for roof, it will be 4 kilonewton per meter square from 28 to 30 range. Click on add. So the flow rate for roof has been added. So we finished defining. Now we will add load case details. We can add first it will be seismic, which will be EQX. First it will be EQX. Click on add. Second will be EQ. Z. Click on add. Next will be dead load, which will be DL. Click on add. Another one will be live load. And then add. Next one will be roof load. Then add close. So all the load has been added. Now we have time to assign the load. So EQX, go to seismic load. In X direction, the factor must be 1. Click on add. So EQX has been added. Now for EQZ, go to seismic load. In Z direction, factor must be 1. Click on add. Okay, so this also has been added. Now it's time to add the dead load. Let me see. Yes. Okay, so dead load will be added first. Sulfate -1. Click on add. Sulfate has been added. The next part is flow load. Okay, so flow load will be, first of all, what was the dead load? it was 4 when you will see here. Now what was the deadload? Deadload of slab 4 kN per meter square, and on partition 4 plus 2 6, so we just add it here, minus 6 kN per meter square. What will be the wide range of it? It will be 3 to, because we are not using for roof, 3 to 27 meter. Okay, click on add. Now the next will be live load. We'll place it first. We'll assign the sulfate, assign to view, assign, yes, so the sulfate has been assigned to view. Now it's time for live load. Click on add. Now in live load, there will be full floor load, which is of 3 kN per meter square. As you can see here, the live load is 3 kN per meter square. So minus 3. What will be the wide range? Same, 3 to 27 meter. Okay, click on add. So this live load has been also added. So next part will be roof live load. Click on add. Roof live load, as you can see here, first dead load 4 kN per meter square, which will be on the roof, and another one is 1.5, 4 plus 1.5, 5.5 kN per meter square. So I'll just go to floor load, minus 5.5 kN per meter square. Range will be 28 to 30. Okay, click on add, close. So we have finished assigning all the loads on the structure. Sulfate we have assigned, we have defined the earthquake, EQX and EQY down. It's time to analyze our structure and compare the result. So go to analysis and print. We need all the data. Click on add, close. Now click on analysis, run analysis. After analysis and run, we will click on view output file. Done. So we have got all results. Now it's time to compare our result. We will move down. Okay. Just keep going down until we find okay. Volumes. Okay, so now here you can see this is a result. So we'll compare this result with our manual calculated result. Okay, so in a manual calculator, what was base shear? 2107.5. What is the base shear here? 2110, which is very close to each other. And what was the weight of structure? Was 50655, 50661, which is also very close. So our analysis has been correctly done. Now we will see much further results, like we will go down for 3 meters and everything. We have the result for 3 meters. The force is 6.02. Okay, now we will see here. For 3 meters, the force is 6.02, which is correct. Now we will go down. Next is 24, which is 24 here. You can see it. So it is also correct. So now you can have got the idea what result we are getting it from here. So this is it. The comparison between manual calculator and STAAD Pro. As you can see, all the factors SMIG is correctly taken 1.042. As you can see here, it is taken SMIG is 1.04, which is also accurate. So that's it. Thank you.